Hello, my name is Angel Garzon, and today we are going to present the project about concurrency in Java with my teammates, Jose Leonardo Peñuela and Edwin Wilches. First, we have the treat. We implemented a basic treat using an iterancy. We create that extends that treat class and overrides the run method. When I call the start method, a new treat is created and executed independently. This example shows how a treat works in a basic level. Second of all, the runable. I used the runable interface. This is another way to create treats, and it's more flexible than extending treat. The logic is defined inside the run method, and then is executed by a treat object. The call center. In this example, we simulated a call center using a treat pool. We used an execute service with three threads to represent three operators. Six calls are processed, but only three at the same time. This shows how threads can be managed efficiently.
Next, supermarket. Sequential versus concurrent. Then I implemented a supermarket simulation. First, I used a sequential version where clients are attended by one. After that, I implemented a concurrent version using treats. In this case, multiple clients are attended are the same time, reducing execution time. Next, producer and consumer. In this example, I implemented the producer-consumer problem. One thread produces data and another thread consumes it. I used a booking QE to synchronize both threads and avoid errors. This ensures safe communication between threads. Wait and notify. I also implemented synchronization using wait and notify. The producer waits if the buffer is full and the consumer waits if it's empty. This allows coordination between threads.
In the number 8, we got matrices. In 2K, sequential parallel. We work with matrices. First, we process the matrix sequentially using one thread. Then we use multiple threads to process it in parallel. The parallel version is faster because the work is divided. In ninth place, we use data parallelism. In this example, we divide an array into parts. Each thread possesses a part of the data. Finally, the results are combined. This improves the performance of the general thread. Then we use the race condition. We also demonstrate a race condition mainly because the two threads modify the same variable without synchronization. This causes incorrect results, and it shows that why synchronization is very important. And in the final, the current thread, we use the current thread method. That allows us to use and modify the current thread. It changes its name and uses sleep to pause execution and works in a better way. Now we are going to watch the program work.
Okay. In conclusion, this project help us to understand how concurrency works in Java. Treats improve performance, but they must be managed careful to avoid errors. Tools like execute service and synchronization techniques are very important. And we are viewing how it's the functionality of this.
that is all for our part. Thank you.